بسم الله الرحمن الرحيم. أحبتي طلبة الصف الخامس، إليكم الدرس التالي عن الموقع، الإزاحة والمسافة position, displacement and distance. The position is a vector quantity, not a scalar, it's a vector quantity. Here we have this runner. This is the initial position xi, and this is the final position xf. We say the object is in motion when its position change with respect to a constant reference point. The reference point may be the x-axis. So if for example, initial position of this runner is x equal 5 and the final position is x equal 12, then the displacement traveled is equal to 7. As we can see here, delta x is the displacement, is xf minus xi, final position minus initial position, which is 12 minus 5, it's plus 7 meter. Plus means we are moving in the positive x direction. The change in position vector is called the displacement. The displacement is also a vector quantity, and it's represented by the straight line between the initial and final position. Now if the runner moved from the position x equal plus 5 meter to the position x final equal plus 1 meter, then the displacement delta x is equal to 1 minus 5, and it's equal to minus 4 meter. The negative sign of the displacement means the object displacement is in the negative direction of the x-axis. Now if the runner moved in displacement, then returned back to its initial position, then the displacement, the total displacement will be 0. Now to understand the difference between the displacement and the distance, assume we have an object at initial position 1 meter, then moved to the position 6 meter. Then the displacement is 6 minus 1, which is 5 meter. This is 5 meter. Then it comes back, returned back 3 meters to the final position, which is x equal 3. Then the total displacement of this journey is 2 from initial to final point. This is 2 meter. But the distance traveled is 5 plus 3, which is 8 meter. So the distance is a positive magnitude always and cannot be negative, and it is a scalar quantity. But the displacement is a vector quantity and can be negative, and here it is equal to 5 minus 3, which is equal to 2 meter. This is the initial point and this is the final point. Average velocity. To evaluate the motion of a moving object, we can find the average velocity. The average velocity is equal to x final minus x initial, which is the total displacement over the time interval, which is t final minus t initial. So the average velocity is equal to the total displacement over total time interval. Remember, the sign of average velocity is the same as the sign of displacement. The displacement is a vector quantity, so that the velocity is also a vector quantity. The average velocity v can be written as, if we have initial velocity and final velocity, then the average can be calculated by this equation: v initial plus v final over 2. Now the graph displacement time as shown in figure 6. This is a graph plotted between displacement and time. This curve represents the velocity curve. If we take 2 points A and B and calculate the slope is equal to delta x over delta t. Delta x over delta t. Then the slope equal to tan theta, and it's equal to delta x over delta t, and delta x over delta t is the average velocity, so that the average velocity is the slope of this graph. The slope of the straight line in the displacement time graph represent the average velocity. Average speed. The speed is a scalar quantity, and it is the ratio between the total distance traveled over the time interval. This is called average speed. The average speed is the total distance over time interval, and we can write this equation in simple forms: v average, which is the average speed, equal d total, the total distance, over t sub t, which is total time or time interval. Remember, the distance is a scalar quantity, numerical quantity, so the average speed is also a scalar quantity. Thank you, have a good day, and goodbye.